Okay, I wanted to walk you through some of these posters to make sure that you've got the process right. And so let's start with this one. So you can see the light is coming in, hitting photosystem 2. And at that point, that energy excites the electron and makes it go through the electron transport chain, which, when it hits this protein, gives it the energy to pull hydrogen through into the lumen. All right, so that's important. That's a piece of active transport because it's working to go against the gradient and build hydrogen inside here. So that electron that's traveling through here, now what happens at photosystem 1 is at a different wavelength of light. So really there should be another light here. A different wavelength of light. This is P700, this is P680. When the light strikes here, that causes an electron to be excited and travel through here. And actually, it's not directly in photosystem 1, but kind of off to the side associated with it, that there's another protein there. And that protein, once it gets the excited electron, will have the energy to take NADP, add a hydrogen with that electron, creates NADPH, and now this is able to go, it's in the stroma, it's out here, it's going to go over to Kelvin. But meanwhile, back here in photosystem 2, because we lost an electron, we need to replace it. And that replacement electron is going to come from water. So water is split. There's an enzyme that sits here, and it splits that water into oxygen, hydrogen, and an electron. And that electron replaces this lost electron and keeps the system going. This hydrogen goes to just build the gradient inside the lumen here. And that oxygen combined with another oxygen is going to become O2, and that's released to the air. So now that we've got a hydrogen concentration gradient being built here because of the hydrogen from the water and the hydrogen that's brought in through the electron transport chain energy, now we've got this enzyme sitting here called ATP synthase. And because this is a gradient, there's going to be a natural diffusion with the gradient through ATP synthase. So that does not require any energy because it's diffusion going from high to low. But that fact that it travels through the ATP synthase causes it to turn. And that physical turning causes ADP to be able to combine with a phosphate to create ATP. So it is that physical turning, because in order to go from ADP to ATP, you must add energy, because going from ATP to ADP releases energy. So now we've got the ATP and NADPH from the light reaction are coming over here to Kelvin. And remember, I told you just needed to know kind of the big ins and outs. We're going to need carbon dioxide. We've already got the ATP and the NADPH. The ATP is going to provide energy here for the construction of this bigger complex of carbon molecules. And the NADPH is going to be providing hydrogen. And after a few cranks, this carbon dioxide, ATP, and NADPH is going to produce glucose. Sending back to the light reaction will be ADP, but also the NADP, which isn't here, but also the NADP, because we're going to need that here. All right, so they cycle around together. All right, let's take a look at this one. So we've got the layer here. We've got photosystem 2, which is correctly labeled. The light comes in at P680, yes. Electron transport chain. This is that protein that brings in the hydrogen. Going over here to photosystem 1, the light comes in, excites the electron. And then this electron transport chain electron will replace the one that's lost here. going into this molecule that has the ability now with the electron to make NADP combined with hydrogen to make NADPH, which is going to go down into Kelvin. And of course, here we have the water being broken, the electron going in, hydrogen adding to the interior of the lumen here, and oxygen is going to go out. And again, the simplified Kelvin, well, this has got the ATP synthase down here, but because the hydrogen is building up, it can go through the ATP synthase and create ATP. That ATP is going to go into Kelvin. And notice that NADP is going to feed back, and ADP and the phosphate are going to feed back. So here we've got the light reaction, photosystem 2, electron transport chain. I don't see the hydrogen coming through here, but there would be hydrogen being pulled through by the energy. Oh, there it is. I'm sorry. There's the hydrogen being pulled through. Then we get to photosystem 2, and then 1, different wavelength of light. NADPH is being created through that energy. That is the final electron acceptor. And ATP synthase here with the hydrogen gradient that's being brought in and built. We have hydrogen moving through. It's not indicated here, but hydrogen moving through, and that's going to power that turning. We have ATP and NADPH heading into Kelvin, and NADP and ADP heading back, and then overall the Kelvin cycle. And product is glucose. All right. So again, light coming in, hitting photosystem 2. Going through, I don't see the electron transport chain here, but there's an electron transport chain that connects to, well, I guess 1 is over here. And so there should be an electron transport chain in between. The photosystem 2 gets replaced by the water, electrons, oxygen, and hydrogen. Photosystem 1 needs to be making NADPH after that. We have the ATP synthase, which is down here. And so there's the hydrogen traveling through and generating ATP, which is going to go into the Kelvin cycle. I don't see carbon here, and I don't see NADPH. All right, so here we've got a thylakoid, we've got some ATP synthase, but be careful, that's not where NADPH is created. Photosystem 2, we need an electron transport chain there, photosystem 1, and hydrogen's inside building, oxygen, I guess is going to be released to the outside. Water is actually broken down inside, right? Water's broken down inside. And then Kelvin, big ins, big outs, carbon dioxide, ATP, NADPH, and then that sugar there is glucose. Here we've got ATP synthase. Now be careful, the ATP is not going to be on the inside. The ATP is on the outside. And the hydrogens are flowing through here. Here's photosystem 2, which is going to use water to split. Here's the oxygen that's going to be released, hydrogen building up. An electron is what goes in here. And that electron replaces the electron that was excited by the light, travels through the electron transport chain, pulls hydrogen through, gets to photosystem 1. There, the electron's going to be excited by a different wavelength of light, and then, again, not on the inside here, but outside, the NADPH is going to be created after the photosystem 1 as the final electron acceptor. Glucose created, carbon dioxide brought in, ATP, NADPH, and then those things get sent back into the light reaction. All right, hopefully talking this through is going to help, and you need to be able to know what happens where for your quiz on Monday.